I started macro model in the previous class. The first model that we plan to consider is the classical model. The classical model, given the assumptions it has, is considered to be a long run macro model. What happens in the long run? The usual feature of a long run macroeconomic model is the economy has attained full employment, which means most of the resources are employed. There may be some frictional unemployment of it, because there are so many opportunities. People, some of them prefer to quit a job which is not to the best of their liking, so they would be looking for a better job. Frictional unemployment. So, long run macroeconomic model essentially has the feature that the economy is in full employment. Now, given our description of a macro model in topic 1, there should be 3 sectors that should be modeled. 1, the goods market; 2, the money market; 3, the labor market. What they essentially mean is we got to model the demand side of the economy, we got to model the supply side of the economy. The demand side of the economy consists of the goods market and the money market. The supply side of the economy contains the labor market. Now, in the previous class, I told you that given some identity or identical relationships in a macroeconomy, in a very oversimplified macroeconomy where there is no government, because the reason why it is convenient and also appropriate to do so is classical macroeconomists never believed that government can do anything good for the country. So, government should not be part of any macroeconomic model, and also we decided to drop government. Now, in this economy, we can think about an income identity, or as a matter of fact, any economy, we can think about an identity, income identity, where the total income is split between 2 items, consumption and savings. Whatever you earn, there is no government, no taxes in this model. Whatever you earn, part you consume and part you save. So, that is an income identity. It is an identical relationship. Income should be equal to, by definition, consumption plus savings. Similarly, in this simple economy, there can be an output identity where our total output of the goods and services in an economy consists of 2 types of goods: consumer goods and investment goods. There is no government goods, no public goods. So, there is only government, there is only private goods, and private goods are 2 types. The ones that we consumers consume, which are called final goods: bread, butter, jam, jelly, automobiles, scooters, whatever, bags, shirts, pants, everything; and capital goods, which firms consume. Consume in the sense they use to produce goods for us. These are intermediary goods. And these investment goods are also called capital goods, which are essentially machines, tools, implements, etc. Now, I will talk about investment later. It is a very broad topic. Given this background, therefore, the output identity would say that the total output of the economy is conceptually divided into 2 parts. No problem. Consumer goods output, investment goods output, find a way to add them up. We know how to add them up. We use base period prices, all right, or if we take current prices, we divide that nominal value by the price level. And a price level in our country, I have told you, there are at least 3 measures of price level: GDP deflator, Consumer price index, wholesale price index. You take any one of them which is available, divide the nominal value by the price level, you get the real value, then add them up. Now, having said that, and given the fact that the demand for goods, just like the income identity and the output identity would tell you, the demand for goods should also be is also an identical relationship, that consumers demand and investment demand. So now, if we make an assumption the consumption demand always equals consumer goods output, you get a very simple relationship coming out. You will see that savings has to match investment demand. I told you, savings has to match the investment demand. So I begin from this point because I need to complete the classical model if I can today. All right. So in the classical model, I am first going to model the demand side, and I am going to model the goods market. And given all these identities, we found that goods market equilibrium condition, which is supply of goods equal to demand for goods, essentially means supply equal to demand essentially implies S is equal to I, where S is a function of the real interest rate, which I assumed I is a function of the real interest rate, and the partial derivatives SR is positive, and the partial derivative here IR. This we have done. The relationship S is equal to I, you can look up your previous day's notes, you will see these identities tell you that if consumer goods output is equal to consumer goods demand, investment goods output is equal to investment goods demand, and there is an income identity, output identity, etc., then savings should be equal to investment. If supply is equal to demand, that equilibrium condition has to hold. Now, this R is a real interest rate. I also tried to explain why the real interest rate matters. The simple reason is that the nominal interest rate, according to Irving Fisher, consists of real interest rate plus inflation rate. In this kind of a static model, first of all, there is no inflation. Prices can change once, twice, but no persistent change in price can be modeled. There is no dynamic variable of price possible. These are static models. So inflation can be dropped. Moreover, there is an economic reason why real interest rate, even in a dynamic model, matters for investment. Some people say for savings maybe something else, but anyway, let's assume that it also matters for savings. Because the interest that you earn from the bank as a saver, one period later, when you put money today, you don't get interest right away, you get 1 year later some interest income. When you spend, if there is inflation, the value of that money, that income has fallen because of inflation. Because inflation reduces the purchasing power. That means you can buy fewer goods with the same money, 100 rupees, because prices of goods have gone up. So essentially the return to you is the real interest rate or real return, not the nominal interest rate, not 14% or 10% or 8%, but 8% minus 5%, 3% is the real return. So can I ask you a simple question? Can the real return be negative? It can be. Nominal interest rate can never be negative, but the real interest rate can be negative if inflation is too high. If inflation is too high, then the real rate can be negative. Say nominal rate is 8%. A few years back, 1 year back, we had inflation of 12%. So what was the real interest rate in the economy? Negative. Simple arithmetic tells you. So that is also something we will talk about that later. Don't think that real interest rate cannot be negative. Nominal interest rate cannot be negative. Man cannot be paying Bank cannot tell you if you deposit money today, you are going to lose money tomorrow. Then you rather keep money at home. So the nominal interest rate they cannot say is negative. We are going to cut your money, reduce your value. It cannot say that. But it can fool you. It can tell you we are going to pay 6% interest rate. And you get very attractive. There was one commercial on TV. Some bank is offering 6% or something 1 percentage point more or 2 percentage point more, and this fellow comes, this fat fellow, the Bollywood actor, says, "Arey, that means 50% more," he says. Instead of 4%, 6% savings account, that means 50% more. Don't say 2% more. That means 50% more income you have. But they are not telling you what the real return is. The inflation may be at that time 8%. So what is the real return? Negative. By the time you receive the income, inflation has gone up. Prices have gone up by 8%, average prices. So these are the things that you need to learn from this, pick up from this course. Some practical or usefulness of this particular, these relationships that we use. Now the real interest rate therefore is important for the savers as well as investors, because investors also gain from inflation. If they borrow money today and have to pay the interest rate 1 year later, 1 year later if prices have gone up, but the cost of production is 1 year earlier, today they have bought the goods, producing and bringing it to the market 1 year later, they get a premium of higher prices on the same product, although the costs are previous period prices. So the inflation premium reduces the interest burden of the companies who are borrowing money from the bank. Am I clear? All right. So you have to be, that's why real interest rate matters. So that was the goods market. The second market that we talked about is the classical model had a very simple money market. This money market, one can say, is there in the writings of the Cambridge economists. One can say it is also there in the writings of American economists like Irving Fisher. Essentially, I gave you the money market equilibrium, supply is equal to demand implied here. Supply is equal to demand implied that real supply of money, M over P, is equal to transaction demand for money, HY, or I wrote another equation from this, MV is equal to PY, where V is the velocity of money. MV is equal to PY. This also I wrote, that the total effective supply of money is money supply that the Reserve Bank has printed and circulated in the economy times the velocity of money. I told you why velocity of money existed, that I spend 100 rupees, in the evening I find my note somebody is using in Rawatpur. So the note is circulating. So there is a velocity of money. Currency is just not used once. When you withdraw money from the bank, start spending it, is just not used once. That paper note goes first to the shopkeeper in the shop C. From there, it goes to somebody in Kalyanpur. From there, it has traveled to Naveen Market. From Naveen Market, it has left Kanpur, gone somewhere else. So there is a velocity of money. So total effective supply of money is equal to nominal income, because this Y is real income into price is nominal income. Now, which is GDP or something like that at current market prices. Now remember one thing, therefore, the money that is required to transact the total value of goods is less than PY. M is less than PY because M into V, where V is a number greater than 1, if that is equal to PY, note therefore M, money that is required to buy some goods and services in a country, the total currency requirement is much less than the total value of goods produced. The simple reason is currency will keep on traveling and do the job for you, for the country. All right. So this is the money market. Now this, the whole thing is the demand side. I will come to the demand function, etc. later, but this is the demand side. Now I come to the supply side. All right. Now on the supply side, They are essentially three items, supply side. One, you have the production function, the macro production function, aggregate production function, which I told you is something like y is equal to f n k naught, y is equal to f n k naught, where f n is greater than 0 and f n n is less than 0. What f n means is marginal product of labor. Why is it marginal product of labor? Because f n is essentially dy dn, n is labor. So dy dn means as n increases in the economy, more people are hired, more output is produced. You can look at it from the point of view of a company. As a company hires more people, it is planning to produce more output. The question is how much extra output? D. In calculus, D is very small amount, so actually D doesn't make much relevance, much sense in economics, but we still use the calculus because it is convenient. We can use the rules of calculus. We can use mathematics in economics. But D, does it really make sense in economics? D is very small change in calculus. dy dn of a function y, function of n, is actually the slope. Slope is measured by the tangent, and tangent is measuring the slope at a very small point on the curve. If it is a continuously changing slope situation, so D really doesn't make sense in economics. When you're talking about millions of tons of goods, hundreds of labor, lakhs of people being hired, all right? But this is the hypocrisy we have, I guess. In order to enjoy the convenience of using mathematics, like calculus in economics, we use these notations. Essentially, to be honest with you, they should be in discrete terms, delta y over delta n or something. Anyway, I'm warning you about these things. These kind of things, shortcomings are there in the discipline. Anyway, so dy dn is essentially called the marginal product of labor. So as you hire more people, what is the extra output you get? As you hire more, what is now the extra? And what you see, that extra for the same amount of hiring, say 10 labor each time, is not giving rise to the same amount of increase in output. It can very well be different amounts. First time it was 20 more extra kgs, next time it is maybe 18 more extra kgs. Next time, the following time period, it may be 15 units extra output, 15 kg or 15 tons or whatever. So this is essentially the marginal product of labor. This is a very important variable, marginal product of labor, which is n. I have introduced labor as n because the capital L I keep aside later for that, that alphabet for some other notations. So marginal product of labor, I use n, and k naught is the fixed amount of capital. And also this production function assumes the technology to be given. It's not going to change. In the long run, it has reached some stable point where the technology, all firms, the entire economy is happy with it, whatever aggregate technology they're using. Aggregation is a problem in macroeconomics. How do you aggregate? Anyway, I'm not going to get into that. So this marginal product of labor, usually, if I draw the production function, you will see it's a downward sloping line. Because the production function Fn greater than 0 and Fnn negative, Fnn is not 0. So Fn keeps on changing. That means the slope keeps on changing. And Fnn negative essentially means that marginal product of labor is falling, is diminishing. So this production function looks like this, which I drew last time. N and y, if you have, starts at 0 point and it goes up like this. It may even reach a saturation point. Saturation in the sense it may peak, after which if more people are hired, output may fall. I told you if there are more students here than the room can accommodate, the knowledge creation may fall because there will be disturbances, They would be sitting on the stairs there, they will be talking to each other, all right. This disturbance, like extra people in Eden Gardens yesterday who were not allowed to enter when the KKR returned after the victory, created a stampede-like thing, and police had to use lathi charge. Marginal productivity or marginal utility started declining because you went there to enjoy and you come back with lathi charged, injured hands and legs and God knows what. It's no fun. That happened because there were too many people who tried to enter compared to what it can accommodate or it decided, whatever, for yesterday's celebration at Eden Gardens in Kolkata. That happened. Similarly, if too many labor is hired by a company, marginal product may become negative. But so no rational company would hire too many people. They're profit maximizers. They're very careful. So they would hire up to the point where profit is maximum. That profit maximum hypothesis finally led to me. So you can see the marginal product of labor is a downward sloping line. If you draw the marginal product of labor here, it will be a downward sloping line. If you draw the FN line here, you can see the tangent is getting flatter. So the marginal product of labor is a downward sloping line. This is called diminishing marginal product. What happens is, compared to in relation to the fixed capital, if you keep on hiring more people, all right, productivity starts falling. It's no longer capital that efficient. So marginal product of labor starts falling, diminishes. The question therefore arises, you can ask me, sir, how much labor then the company would hire? What will be the labor demand function? So the question that comes next is B, what is the labor demand function? Well, it's very simple. Given the diminishing marginal productivity of labor compared to fixed capital in the long run, if labor is hired from the profit maximization hypothesis we obtained in the previous class, that profit maximizing firms decide that, get this following condition. What was the condition we got? We got PFN, it was small f, small p, I guess, for a firm, PFN is equal to omega, where what we obtained was that some small y the company produces using small n amount of labor and some fixed capital, small k naught. And given the profit maximizing hypothesis in the previous class, I showed you that this PFN is equal to W was the first order condition of profit maximization. So how much labor would be hired is a very simple thing. If you know the value of P and W, then you can compare Fn with P and W, which is Fn is equal to W over P. This one essentially means that Fn has to be equated with omega over P for a company. So for the macroeconomy, it will be capital Fn is equal to capital W over capital P. So we need the capital W over capital P number. Once we have that number, suppose that number is something, suppose this is the line which measures capital W over capital P, some value is given. So now you ask, how much labor do the economy hire? Well, the labor would hire, given the profit maximization intuition we have from the company level, at the aggregate level, if we follow that up, then it will be capital Fn is equal to capital W over capital P, which is at this point, this is the amount of labor that the economy would be hiring if there is some W naught and some P naught value given to me. Now, sir, if W naught or P naught changes, does the economy hire more or less people? Yes. Assume W naught and P naught to change so that say W1 and P1 both has fallen. and the number ratio has also fallen, or say W1 has fallen, P0 has not. So suppose you have a situation where you have now another line where it is some W1 over P0, where W1 is less than W0. So the economy has a lower wage. Oh, companies are higher, lower wage they have to pay to the labor. Say a contractual wage. Oh, they are feeling very good. So costs are down, price has remained the same, the companies feel happy, so companies immediately respond at the macroeconomy, at the macro level by hiring more amount of people. So the labor employment goes up, whereas the wages fall, which is called real wages. Remember, W over P is real wage. W over P is equal to real wage. W is nominal wage, P is price, which is of course nominal always. So you can see that a labor demand function emerges. How does the economy's labor demand changes? Well, labor is demanded by companies. If we assume companies to maximize profit, then the profit maximization hypothesis leads us to a company's demand for labor as well as the macro labor demand function. And what it is essentially that it will come, what will be the labor demand function for the macroeconomy? It will be Fn is equal to W over P, or Pfn is equal to W, whichever way you want to write it. You can write it as Fn as Fn is equal to W over P. And that's the labor demand function, which I called initially marginal product curve, is like a demand function for labor, because we move along that line as W over P changes. If something shifts Fn, then we move along the new Fn curve. Suppose technology has improved, labor is more productive, so same amount of labor is producing more, giving more output because the technology has improved. Microsoft has a new software, so everybody's output has gone up. All right? Then we move along that, and that becomes the labor demand function. So Fn is essentially the labor demand function. And the equilibrium, and how much labor is demanded, I need one more information. I need the information on W over P. Because the first order condition says it has to be Fn is equal to W over P. If I know Fn is good, from the production function I know Fn. From the production function I know Fn. All I need is W over P. As soon as I have the information, which is called real wage, then I compare Fn with real wage. And I demand when marginal product Fn, marginal product, is equal to real wage, W over P. Any problem? Any problem with the labor demand function? It comes from the production function. Except I introduced the profit maximization hypothesis of the companies. I did what is called in macroeconomics a micro underpinning of macroeconomics. That is, I use micro theory to understand what may be going on at the macro level, then I aggregate that. That's all. So for micro theory for one firm, I used small p, small f, small n, small w as notations. For the macroeconomy, I'm using capital P, capital F, capital W, these notations. So the labor demand function is essentially, therefore, what it means, therefore, the labor demand function is, macro labor demand function is essentially Fn is equal to W over P. Macro labor demand function. This is the macro labor demand function, which I tried to demonstrate with the help of some micro theory. If you want to learn micro theory, you can open a micro textbook. All right? Micro theory, micro textbook. Is that clear? Now, our supply side story is not over because we don't have the labor supply function yet. How can we talk about equilibrium if we don't have the supply function? Because the equilibrium concept requires supply is equal to demand. In the labor market, I have only the labor demand function. For that, I had to have the production function first. Then I had to have a micro theory of a firm, theory of firm, to get some intuition. Then I have the macro labor demand function in that yellow color. So now I require the labor supply function. If you are comfortable with this, I can go to labor supply function. How to obtain that? Labor supply function again uses another area of microeconomics. So given that you guys have no background in microeconomics but still have to take this course in summer and you have to learn this, what we have to do is I will try to give you a very simple exposition of the micro theory behind labor supply function. Like I gave you a simple exposition of the micro theory behind labor demand function. So I'm going to give you a very simple exposition of the micro theory behind labor supply function. Now, who supplies labor? Can I erase this part of the board? No? Okay. Who supplies labor? I will write the entire classical model later. This is what I am developing. Who supplies labor? Well, households supply labor. If you remember that circular flow diagram I had in topic 2 when I started measurement of aggregate economic variables, you notice that the households supply labor to companies. So the question is, like the demand and the supply function both are drawn against prices, the labor demand function is drawn against W over P, will be drawn, you will see. Fn, you can call that labor demand function, drawn against W over P. So we would like the labor supply function also to be drawn against W over P. So can we think about some microeconomic theory to explain how labor supply would change with W over P? That's the question we have. So part C, A, B, now C, labor supply function is something that I am going to work upon. Labor supply function. Now, let me see whether it makes sense or not. The micro theory is a very funny theory. It says any householder maximizes his utility satisfaction, whatever it is, utility satisfaction, from two things he gets. He works and earns an income and he gets satisfaction from income because he can spend the income on goods. He can go on a vacation, go to rave, party there, provided don't get caught. You know what happened after IPL game in Bombay? They got caught. So there is no more fun. Then it is dissatisfaction, disutility. Then it is you are having disutility from a good income. You have income but you are getting disutility because you got caught, you were doing an illegal thing, and where is the fun? To go to jail, and on national TV you are also on. Everybody can see you. These famous players. The more famous you are, more trouble you can create for yourself. If you are not famous, who cares? You know, who is this guy? There are so many people on TV. Who wants to know who they are? But if you are famous and caught, so utility you can get from income, if you earn income because you can spend, but utility you can also get the way I get, for instance, from leisure, doing nothing, chit-chatting with friends, sitting on the lawn till 2:30 or 1:30 at night till the canteen is open. Acha, let's come back to the story I want. And utility maximize is something which a rational consumer does. Although the utility may lead to disutility, but I am not going to talk about that. So if they are maximizing utility, you can say a consumer maximizes utility U, which is a function of, say, two things. One, his income, total income, real income, and say leisure, LS. Leisure is what you enjoy as not doing anything, not working, watching movies, chit-chatting with friends, staying up late at night, whatever, going to rave party provided it's not an auto. Achha. So maximize utility, but usually in microeconomics we say this maximization in particular, maximize utility is subject to a budget constraint. That is, he cannot just maximize any unlimited amount, it has a budget constraint. The budget constraint involves prices, etc. So it maximizes utility subject to budget constraint, which he says is y is equal to W over P, the real wage. Suppose it's in individual terms, small w and small p, W over P into 24 minus LS. So here is the budget constraint. LS is leisure. You are 24 hours a day. If you take leisure, per hour you earn W over P as the real wage, real income. So the total income is number of hours you work. Suppose you work for 8 hours. That means 12 hours is leisure. 24 minus 12 is 8. The 12 hours you do leisure and other activities. Leisure also encompasses all sorts of other activities. Having a bath is also part of leisure. Having food is also part of leisure. All right? Beating up somebody may be also part of leisure. Running, jogging, part of leisure. Whatever. When you're not working, you're not earning. And you are earning W over P, say, per hour. So total income will be Y. So this is the constraint. Now, if you draw the constraint against an axis, a diagram suppose, you draw that, a diagram, if I draw a diagram, then how will it be? It will be, suppose you have leisure and you have Y on this. The two woods from which you get utility. How would the budget constraint look like? It's a linear line you can see. When leisure is 0, it is 24 into W over P, which is Y max, maximum Y. You're not sleeping, you're not having a bath, you're not eating, you're working 24 hours, which is not possible. Hypothetically, it is a possibility. In reality, it is not a possibility. Nobody works 24 hours. So there's a maximum point here that you get, all right, which is Y max. And then you have all leisure and no income is 0 income. Leisure is 24 hours. And it will be a straight line where maximum leisure will come, all right, LS maximum. And the slope, this alpha, tan alpha, is equal to minus W over P. Tan alpha would be minus W over P. Slope of the line, please check. You say I'm correct or not. Mathematics, my mathematics is terrible. So minus W over P, tan alpha, all right? Now, this utility function has some convexity property. So for a particular level of U value against Y and L, they are convex in shape. So maximizing utility essentially means I'm reaching the maximum point of tangency, because after that I cannot reach. Below that is under satisfaction. So the optimum point is at the equilibrium point. So when you have that, you can drop a line here and you can find an LS value, say LS0. All right? What is the LS maximum? This is 24. LS maximum here is 24 hours. All right? LS0. Now, suppose I give an incentive to the householder. I say, you're going to get a higher wage. The poor fellow hasn't been earning enough. Working is not. But with the higher wage, he gets very excited and he starts working harder. So what would happen is that at a higher wage, this budget line will start increasing. It will become steeper as, say, as W over P increases, the budget line becomes steeper and the person works harder, and suppose he reaches an equilibrium point now where he consumes less leisure, which would happen to you tomorrow, and he works harder and earns a better income, better life. his satisfaction level goes up. Say suppose at a lower wage, whatever I'm working, now with a higher wage I get an incentive. This is an assumption I'm making, leisure, and W over P is like a cost of leisure. W over P is the cost of leisure, because if you take leisure, you miss W over P earning, so it's a cost. By taking leisure, you don't get W over P. If you get W over P, then it is not a cost. So W over P is like a cost. So if the cost goes up, cost of leisure goes up, what I'm saying, as the line becomes the yellow line, because W over P has gone up, it has become a yellow line, the consumer consumes a different amount of leisure, which is LS1, on a different indifference curve, which is the yellow indifference curve. All right? Now note one thing. Therefore, as W over P goes up, it implies leisure falls because cost of leisure has gone up. It's very expensive, it's costly, bhai, to give up work. We rather work and earn because leisure has become very costly. Suppose I make marks in or question papers tougher. So leisure is becoming costly for you. You rather work. Previously, at a lower cost, when you can enjoy a lot of leisure and study a little bit before the exam, the night before, I've seen people doing it, get a good marks the following morning, and you call them very brilliant people. Suddenly that man is no longer brilliant. Question papers have become so tougher, just opening the pages the night before is not working. I've seen it happening, to be honest with you. This is what I'm trying to say. All right? So you have to work harder. And people like his wife is saying, suppose the married man is saying, why don't you go and work, earn more, you have a better life. So suddenly with a higher income, he gets an incentive, starts working more. So when leisure falls, what happens to the number of hours he works, N? Capital N was total number of people or total number of hours people are hired. Small n, what happens? Small n is 24 minus leisure. So as leisure falls, 24 minus n goes up. This thing increases, so number of hours he works or they work, or number of people employed in the economy goes up. As leisure goes up, 24 minus L then, as leisure falls, 24 minus LS will go up. So this gives you therefore the labor supply function. If I can sum up this story and can write a labor supply function like this, find out, is say some Gn, some functional notation Gn is equal to W over P, and this relationship is an implicit relationship. And what I'm saying is that this G subscript n with respect to W over P is greater than 0. This labor supply, this represents the total supply implicit function of labor. This Gn is positive, means as W over P increases, number of hours working increases. But there is a catch. This labor leisure diagram, the trade-off, is true up to a point of increase in wages. Beyond that, the person might say, now wages have gone up so much that I can afford to work lesser number of hours. His mind will now shift to the leisure, although the cost of leisure or the opportunity lost because of taking leisure, which is W over P, which you don't earn if you chit chat with your friends, you don't get good marks, you spend too much time with your friends. But now I reached a point that it's no longer important to me. So that positive relationship with number of hours working, or the inverse relationship between W over P and LS may disappear, may get replaced by a relationship which becomes my positive, a perverted relationship. So as W over P increases, I increase more leisure because I have enough. Earlier I used to work 12 hours. Now with 8 hours of work, I earn more than that. I don't need to work 12 hours. So I go back, as W over P increases, go back to enjoying more leisure and working lesser number of hours. So the labor supply function may become perverted after a point of W over P increases. If you have a spectrum of W over P from being very low to a very high value, somewhere in between it switches the relationship, becomes a different one. Up to a point, this is true. So I have heard the CEOs and the big babus of companies, actually, they earn the maximum too. The other day, some company, Apple or some company's boss, refused some hundreds of millions of dollars of extra income. Refused. He said, I'm not going to take it. It was on national TV or BBC. I thought, why did he do this? Well, one reason is the company economies are in recession. So if I don't take that money can be given to shareholders and the share prices will go up, etc. It can be reinvested in the economy, in the company. He decided not to take it. Who can afford not to take it? Who already has a lot also. That's true too. It's not Gandhiji's sacrifice. He already has so much, he can afford $50 million, give up. It doesn't make any sense. He's a billionaire. Apple or somebody's CEO. It was on news. I'm not joking. Just amount I've forgotten. Acha. So he refused that dividend extra because he also owned shares of the company in addition to being a CEO. So dividend income or bonus, what they called, he refused the bonus. So here is a guy who, in fact, you will see, earns much more than anybody who works fewer number of hours. He plays golf. He does the work indifferently. He plays golf. He travels. He meets people. He socializes. That is part of his job instead of doing that work sitting in the office or in the boardroom. Yes, you wanted a question? You had a question? Very good. The company may not be economies are in recession. The companies may be doing well in some parts. They are multinational companies. All right. So in Asia, they is doing well probably. In China, it's doing well. Except Japan. Japan may not be. India is doing well, but it may not be doing that well in Europe. The boss is one global boss who was offered a bonus, and he refused. Let me find the news if I can find. About 2-3 days back, old news only, not very old. So what I'm trying to say, at a higher level of earning per hour or per day, whatever, I did it per hour here, 24 hours per hour, you will see a person can refuse even if wages go up. They know they are sacrificing a good amount of income by not working and refuse it because he already has a lot. His saturation point has been reached in terms of money income. So he rather enjoy. In fact, a CEO works less than number of hours. You know what he does? He makes phone calls. He plays golf where he socializes with other CEOs. All right, he goes to parties. And when you join office, you work 12 hours. He may be working 4 hours. You may not find him in office for months or weeks maybe. But his earning doesn't reflect that. He earns the maximum probably per capita earning in the company. So what I'm saying, I'm summing up this relationship as a positive relationship, the Gn greater than 0, which is W over P, all right? Greater than 0 basically means you have a higher amount as W over P increases, more number of hours you work. So this is the labor supply function. Yeah.
When you said that W by P increases, you also change the indifference curve.
W over P. At some point, indifference curves may change, but indifference curves come from the utility function. Utility function is continuous U. You so pick one U value and find out the various combinations of the two arguments, which is Y and LS, that can give you that value.
When do you change the
Utility
utility function?
function can shift. As I said, the CEO's utility function will be different from you. So after a particular income level, given the surrounding environment, it can shift. It can become a different one. Where higher W over P will give you tangency points, what will happen is this. Utility function, when it shifts, higher W over P means this budget line is becoming steeper and steeper. You have agreed with that? Okay. Now, if the budget line is becoming steeper and steeper, what is happening is, suppose after a point when it has become very steep, say this pink color or brick colored line, you don't get a tangency point where Ls is declining anymore. You may get a tangency point where Ls has started increasing. So there is a shift in utility function. The original utility function doesn't exist anymore. It would have shown points going towards y-axis. But now the new utility function of that same individual, but because his surrounding, his life has changed so much that he now gets preference for a higher W over P, which is a steeper line with more leisure. Look, this point is clearly saying his leisure amount is increasing now. Because leisure is measured on this axis, zero value is here. So it is increasing in this direction. Clear? That is the shift in utility. Microeconomics is a wonderful subject. If you are going to read, I will show you books, very easy books to read. This is all based on micro theory. So given this micro theory, the macro theory is going to assume, what I'm going to do here, is that the labor supply function is an upward sloping line against W over P. And the labor demand function is a downward sloping line against W over P. So now I can complete the classical macro model. Now I would concentrate on the algebraic part of the model and try to solve it like a mathematician. The conceptual part is over. First, we will have the goods market and the equation was SR is equal to IR. This is equation 1. Then I have the money market. Which is M over P. Let's assume money supply to be given M naught at a given point of time is equal to HY. Money market. Then I have the production function from the supply side, which is Y is equal to Fn K naught, Fn positive, Fnn negative. This is the third equation. Then I have the labor demand function, which is Fn is equal to W over P. Then I have the labor supply function, which is Gn is equal to W over P. This is number 4, this is number 5. So essentially I have 5 algebraic relationships to describe the macro model. 5 algebraic relationships to describe the macro model. The first 2 is the demand side. The last 3 constitute the supply side. So I have this macro model in front of you, which, so far I know, this is the algebraic description of the classical macro model. It didn't develop overnight, it developed over a period of time, year after year, with the writings of people it developed. So now, in a simple knowledge of equations, we know if there are 5 equations, there has to be 5 variables at least to be solved, so that it is a determinate system. Now, it can be an overdetermined system or underdetermined system also. Suppose you have 5 equations but 4 unknowns, so one of the variables may have more than one solution. So it is an overdetermined system, and you have an underdetermined system also you can have, where you have 5 equations but you have 6 unknowns. So you have to assume the value of one of the unknowns. to be solved, all right, to be given a priori, and then we can solve the other unknowns. If that value changes, again the numbers will change. In this case, let's assume it's a determined system. So 5 equations, 5 unknowns. So the question that I am going to ask is the following. What are the 5 unknowns? What are the 5 unknowns? 5 equations, 5 unknowns. What are they? What are the 5 unknowns? The 5 unknowns that I can see that need to be solved by the model. One is S and I, the 2 lines, the diagram that I drew would resolve the issue of what the value of R is going to be. So R is one of them. One is R. Next, from this equation I can see there are 2 unknowns. Clearly, I don't know the values. One is P, one is Y. I don't know the value. So P, Y, the 2 other variables coming. P, Y. What are 2 more? Well, when I come here, I can see 2 more. One is, well, I don't know what the value of N is, how many people are employed. It will be given by the labor demand, labor supply function. So what is the value of N? I don't know. And of course, if P is given, I don't know what the value of W is. So I will have the other 2 as N and W. If I say so, it's a determinate system where you have 5 equations and 5 unknowns. The question is, how are we going to solve them? All right? Okay. The essential thing about the classical model is very funny. Look at the supply side first. One unknown, N is solved. Once N is solved, K value is given. If N is plugged here, what is the number that I get? Y. Once Y is there, look at this equation 2. 2 unknowns were there. When Y is there, P is known. And this equation is completely independent. It only solves for R. Model is solved. It's not a simultaneous equation model. It's called a recursive model. One part of the model is solved first, then the values are used for the other part of the model. It's not a simultaneous equation model. X and Y, हम लोग स्कूल में सीखते हैं, class 7, 8 में. 2x plus 3y is equal to something, then x plus y is equal to some number, solve for x and y. Simultaneous equation model नहीं है. Demand and supply line, when we draw, is a simultaneous equation model. The demand and supply together intersect and determine the values of the y variable and the x variable together, simultaneously. So the demand and supply line when we draw is essentially a simultaneous equation model in algebraic terms. Diagrammatically it is a demand line and a supply line. They intersect and I talk about equilibrium. But in mathematical terms, a demand and supply diagram in economics is essentially a simultaneous equation model. So here in the labor market, you have a simultaneous equation model, small model, sub-model. The labor supply and the labor demand would intersect to determine the value of W over P and N. It's clearly a simultaneous equation model here. But the rest of the model is not. The entire classical model is not simultaneous. The labor market is simultaneous equation system. So this part, if I draw a diagram, what will the diagram be? If I draw a diagram, it's a very simple diagram. It is saying I have N value here, W over P here, a labor demand function Fn, and a labor supply function Gn. It's a simultaneous equation model which simultaneously solves for W over P, some value or 0, and N value. What is this N value where labor demand is equal to labor supply? What is the name of this N value? The labor demand equals labor supply in the economy? Full employment. So this is a very specific N. This N value is called NF, which is full employment, level of employment. This is full employment point. This is the full employment point, right? So this is the simultaneous equation model. A supply and a demand line together would solve two variables simultaneously, W over P, which is real wage, and N, the amount of employment. And that employment is a very special employment. Is labor is equal to market. Labor market is clear. It's called labor market clearing. Labor market is cleared means there is no supply, no demand for labor that remains. All are met, whatever they want, at that wage rate. It's called full employment, level of employment. And then what I said, if you have the N and the W over P value from these two equations, I can go to the production function 3 and solve for Y. So essentially what I'm trying to say is that if you draw above this a small diagram, which is the production function diagram, which is N, and this line is Y, and you have the production function, then this value of N is now, I can go to the production function and can obtain the value of Y, which I can call YF, full employment level of output. YF is full employment level of output. Because I have full employment, level of employment. So I go to the production function, get YF, which I said, when 4 and 5 has been used, go to 3 and solve for Y. Because you have the end value. Let that diagram show you see. That is the full employment, level of employment. This is very important, this diagram to be seen. Here, and once you have Y, N and W over P, you don't have the individual value of W and P. Once you have Y, N and W over P, you can go to number 2 on the board, the money market equation. You have the Y value. So what is the value you get from the number 2 equation? P. And you have the value R already from 1, a single equation. R value, savings is equal to investment, equilibrium condition in the goods market. R value gone. So all that remains, R is done, Y is done, N is done, and W over P done. But I need the symbol W and P. So I need the P from 2. If I have P from 2, where would I get W value? How would I get the W value now? Any of the equations, labor market equation 4 or 5? W is there, I can get the value W from any of these equations. My model is solved. The 5 unknown numbers I have, once I have the functions. Alright? Clear or not? Clear? Alright. Have I resolved the issue of solving the classical model? Yes or no? It's up. There are small sections which are simultaneous equation model, like the first one. Savings and investment, it comes from a simultaneous equation. Savings line, they together determine the value of savings and investments, and R. To remember that diagram, savings line and the investment line diagram in the previous class. Then this labor market 2 equations, labor supply and labor demand, also a simultaneous equation model. You have the simultaneous equation model. So you determine the W over P and N value. Then the production function gives you output value. Then the money market equation gives you price. Problem solved. But my job is not yet over. I have a few more things to tell you. I've solved the classical model. I set up the classical model. I've solved the classical macro model. But my job is not yet over. So can I get into the next stage? All right. I would erase only, I require this diagram. ये जो diagram है, labor market and production functions, It comes from the supply side. I have the entire supply side equation there. Okay? So where is the supply curve? You can ask me, sir, you have written the supply side equation, but where is the aggregate supply curve for the economy? Where is the supply curve in this model for the economy? You can ask me that question. Now what will be the supply function? Well, from day one in economics, we know a supply function is a relationship between output supplied and price. So, sir, how do we get output supplied and price? Okay. Now, the issue is resolved here in the following manner. If labor market clears like this, all the time it will happen, whatever be the value of W and P. You see, here if W increases, okay, we are assuming therefore the P would also increase because it has to be only W over P. Because if W increases or doesn't increase, or P increases or doesn't increase, this function comes from the production function. The production function has no P, no W component. And this labor supply function has also coming from the utility function, etc., for given W over P. If they don't shift, there is no reason this intersecting point is going to change. Therefore, if W or P changes, what must be happening in the economy is proportionately the other variable would also change, so that the ratio value W over P doesn't change. Because this diagram doesn't allow that to change. This diagram doesn't allow the N value to change. If W or P were attached to these functions like P into Gn, or W into Gn or something, or P into Fn or W into Fn, if W and P value changes, these lines would have shifted. But there's no reason why these lines would shift. One is coming from the production function, one from that leisure utility model that I showed you. That's not going to change. So what is happening in this model, therefore, the story is, if W over P has to become a constant in this model, employment has to become constant, which is at full employment level. There's nothing that these lines are changing, will change. All right? Then, if any of these variables, W or P changes, the other variable must be changing proportionally. For instance, if wages in the economy doubles, companies have to pay higher wages, that double the wage to workers, then according to this line, if you have reached full employment, then the companies would also double the prices at which they would sell the goods. Because they see their costs have doubled, so that they would also double the price, so that real wage doesn't change, so that their profits don't change. This is what is happening. So essentially this line is saying one very important thing, that W and P are fully flexible variables. And if W changes, then P also changes correspondingly. Okay? Similarly, if P falls, then W would also fall proportionately. So that W over P never changes. Alright? If that is the case, then what will be the aggregate supply line? Well, the aggregate supply line is very simple. I draw two more diagrams here. Here I draw a 45-degree line where I put Y and Y. This output level along a 45-degree line tells me that this is the full employment output level. Now I have one more diagram here, which is the aggregate supply line, which I have Y, and price. This is my YF, because that was my YF. That was the YF translated to x-axis from y-axis. It is on y-axis, translated to the 45-degree line to the x-axis. From the x-axis I come to YF. There is no mention of prices here, whatever be the price. So the aggregate supply line essentially has become a vertical line. This is the aggregate supply line. This is the classical aggregate supply line, which is output fixed at full employment level. Once it reaches full employment, no matter what the prices are, all right, it remains there in the long run. If prices double, then in the labor market, wages also double, so real wages don't change. If real wages don't change, then the other variable on the x-axis, NF also. So NF doesn't change means YF doesn't change. Unless production function changes, which I'm not assuming right now, technology is given, capital is given. Therefore, I have the aggregate supply curve in the classical model to be a vertical line. That is, it is independent of prices once it reaches it. Like the labor market is independent of prices. Whether the price of labor you're talking about, W, or the price of goods you're talking about, P. W over P gets fixed. N gets fixed. Once they are fixed in the long run in this model, they never change. Given the assumption W and P are fluidly flexible. So if W doubles, P would also double. If P halves, W would also halve. So the aggregate supply curve is a vertical line, like a wall. It doesn't change, it doesn't have a slope. It's not a normal supply curve, which is upward sloping, which says, as price changes, amount supplied in the economy changes. It doesn't have that feature. It's a vertical line, perfectly inelastic. They are called a perfectly inelastic curve. Inelastic means it doesn't respond to price changes. Either a supply curve or a demand curve can become perfectly inelastic. Perfectly inelastic in our day-to-day life, for instance, I will give the example of cigarette smokers. Cigarette smokers cannot live without cigarettes, whatever be the price. They keep on smoking that. Or, say, an addicted person, addicted to drinking. He cannot live without drinking. So whatever be the price, whatever may be the condition of his health, whatever may be the state of affairs at home, he keeps on drinking. He's addicted to it. It's perfectly inelastic line. Perfectly inelastic curve. Alright? So aggregate supply curve in the classical model is a perfectly inelastic curve. Perfectly inelastic curve. A perfectly inelastic curve doesn't show any change. Look at this. When you solve employment, W over P number is not required. You equate the two equations and N is solved. Without taking recourse to W or P value. That means W over P also gets fixed at a particular number. Now the question is, how does it remain fixed? Given the assumption W and P are fully flexible. So if W ever changes, P also proportionately. So the aggregate supply curve is vertical. Am I clear or not? Have you understood this part or not? Alright? Now you are saying, sir, ये तो supply curve और बना दिया. Now what is the demand curve? अब तो supply curve बना दिया. What is the demand curve? ठीक है? Are you alright? Okay. So what is this diagram? Now what is the demand curve? That you have made the supply curve, what is the demand curve? You tell me from these two equations, how can I get a price and Y relationship? In the first equation, there is no P, no Y. So I cannot use that equation to get a demand relationship. In the second equation, there is a possibility of P and Y relationship coming. In the second equation, P and Y relationship, which can be the demand function. What do you think will be the demand function? How would it look like? How would the demand function look like? The second equation does give me, this is the demand side equations, money market and goods market. Unfortunately, goods market is redundant. It doesn't have a P value, doesn't have a Y value. It won't be useful for you to get a demand function. So I'm going to get the demand function. There is one way I can get a demand function, a relationship between P and Y, is from the LM equation. From the money market equation. Okay. From the money market equation I can get this. How would the relationship be between P and Y? You can see here that N naught is constant H is constant. So P into Y is a constant. This equation alone will give me the demand function. And you can see that in this demand function, Py is equal to m naught over H, which is a constant. So what kind of a demand function is it? On a Py plane? On a Py plane, what kind of a demand function is this? A rectangular hyperbola. It's a rectangular hyperbola. Am I clear or not? It's a rectangular hyperbola. So I have a demand function like this, which is aggregate demand function. It's a rectangular hyperbola. I have written the demand side. These are the things I was trying to tell you. Supply side. So supply to line will gap. What is the demand line? We need the demand line also. But when I look at the demand equations, one is redundant, not useful, because there is no P, no Y. The second equation is possible. It gives us a hint that there is a demand function possible. So it is Py. Alright? So what this model said, what did I tell you? When the supply side solves the employment level and the output level, I go to the demand function to solve for P. So the classical model essentially says that output or employment is at full employment level, and prices in economy can be anywhere. It depends upon the demand function. So what you are essentially saying, therefore, if you superimpose the aggregate supply line here, then aggregate supply solves for YF, and the demand line depends where it is, the rectangular hyperbola, would solve for the prices in the economy. That's what you are saying. If demand shifts to AD1, all that happens is the prices in the economy will also increase. Output employment doesn't change at all. Labor market में कोई disturbance नहीं होता है. Output employment change नहीं होता. Production function, I am assuming there is no disturbance. So all the demand side does is passively decides the price. The supply side is the powerful one, which decides the employment and output in the labor market and the production function. But once it is decided, nobody can change it. The demand side comes passively and says, अच्छा बाबा, मेरा एक काम तो है, कम से कम मैं आपको बता रहा हूँ price कितना होगा. And the goods market is the most lonely guy. It is not interacting at all with the rest of the model, and the goods market alone says we only determine one variable. What is it? Real rate of interest. And of course the amount of savings and investment. Of course. Because once real rate of is known, savings and investments are function of real rate of interest. So once real rate of interest is known, the economic savings and investments are also known. It's a very lonely fellow. It sits alone there, doesn't interact. The rest of the economy at least interacts. First, there is a simultaneous equation system here, labor demand, labor supply in the labor market, goes up to the production function, tells you what the output levels are. Once you know that, then you go into the demand side. Recursive, these are called recursive models. A part is solved first, you get the numbers, then you go to the other part to solve the other things. Recursive, not simultaneous. So you go to the recursive side, you go to the demand side, and then all you do is resolve the issue about price, what that price level is going to be. That's all you do. In some sense, a very inactive role, passive role, not inactive, passive role. And the goods market is the most funny one. The lonely fellow sits there, doesn't interact with anybody, doesn't bother anybody, only decides the real interest rate. Once it is decided, the savings and investments are known. The numbers are known. Alright? Now you tell me, before I go to other things, if money supply increases in this model, what will happen? which is a conventional way of talking about monetary policy, government policy. Government G is not here, but central bank is also considered to be part of the government or policy issues, indirectly. Alright? Suppose central bank pumps in more money into the economy, cash, somehow. बैंक को दे दिया cash. बैंक को पता लग जाओ आप इसको कंपनी को दो लोन लेकर, in the form of loan. What would happen if more money is pumped into the economy? M increases. Prices would go up proportionately. Nothing else will happen. Y is fixed from the supply side. Velocity of money or transaction demand coefficient H is fixed. Velocity of money is inverse of that. And all that happens is, as money supply increases, prices increase. In fact, if money supply doubles, prices would double. Just like the labor market, if prices double, wages would double. Similarly, in the money market, what you happen is money market determines prices, and if money supply increases, prices would double. Nothing else would happen. The demand function will shift up and pricing would increase. The annual supply curve remains there like a silent spectator, doesn't change. Completely independent. Alright? Price would go down. So what you conclude from this is, if government wants to influence the real variables, like output, employment, through a policy called monetary policy, which essentially means, in very simple words, pumping in more money, or wants to control whatever, it cannot do that. Only thing it can control through monetary policy is inflation. If there is too much inflation in the economy, it can reduce money supply and lower the prices, and the inflation rate will come down in a dynamic setting. Monetary policy has no active role in influencing output or employment. In the classical model, the output and employment is entirely determined by the supply side. ये इधर है. और monetary policy जो demand side से आ रहा है, ये बेचारा एक ही काम कर सकते हैं, price को कम करना या price को बढ़ाना. Nothing more than that it can do. Which is a very damaging conclusion. Damaging in the sense, the conclusion is, you can write it down. Therefore, in the classical model, monetary policy is completely ineffective. Ineffective in what sense? It is not ineffective in the sense prices it cannot control, but it is ineffective in the sense it cannot influence the output level or the employment. Y or N, it is ineffective. Ineffectiveness or effectiveness is judged from the point of view of a policy's influence on the output level or the employment, or both. So monetary policy in the classical model is completely ineffective because it cannot influence either the output level Y or the employment level N. All it can do is to have an influence on prices. Alright? In the classical model. Is it clear? In the classical model, all it could do is influence prices. The ineffectiveness you have understood, not in terms of price control. Ineffectiveness in macro policy is judged in terms of their influence, of a policy's influence on government decision, influence on output and or employment. That is most important. So this is it. All right? Now, one last point I want to mention before I close today. You have seen one thing, that the labor's market has determined 2 or 3 real variables. What are the real variables they have determined? Employment, output, no, our price is the nominal variable, right? Employment, output and real wage, W over P, it has determined. Okay? Then you go to the goods market, it determines another real variable, real interest rate. The only nominal variable we have in the model is prices, which is determined by the demand function. number 2, equation number 2. Once you have that, then from the labor market you can obtain the value as a deduction. Obtain the value of nominal wages, W. But one thing is very clear to you, that once the real sectors of the economy have been determined, what their numbers is going to be, the nominal sector doesn't influence it. Money supply can only influence prices, and prices can influence money wages in the labor market. Real wages are untouched, employment is untouched, output is untouched, even the interest rate is untouched. This real sector, completely independent of the nominal sector, like money supply or prices, is called the famous proposition we find. It's a result. It's not a hypothesis, it's a result of the classical model. This is called classical dichotomy. Classical dichotomy essentially says that the real variables are independent of nominal variables. This is very important. Real variables are independent of nominal variables. Classical dichotomy says real variables are independent of nominal variables. We just saw that. If nominal variables like money supply changes, it doesn't affect real variables. Dichotomy is what? The English meaning of, dictionary meaning of dichotomy is division, breakup. This side of the class and that side of the class, there is a complete dichotomy. This side of the class, what it does, doesn't influence that side of the class. And also say the other way around. Alright? So classical dichotomy is a famous result which emerges from the classical model assumptions, where policy ineffectiveness, etc. are discussed. And also a very important result that emerges, which you may find in textbooks now, is that there is a classical dichotomy in the macro model, where real variables are completely independent of the nominal. But are nominal variables completely independent of real variables? Suppose I shift the labor supply function, employment would change, real wage would change. Suppose I shift, this is the last point, I shift the labor supply function. कोई कारण इधर कर दिया. Real wage will come down in the economy, employment would increase, output would increase, 45-degree line would give me a vertical aggregate supply to the right. Demand function is there, prices would fall immediately. If the vertical aggregate supply for some reason shifts, suppose the labor supply function shifts for some reason, the real wage in the economy drops, the employment in the economy goes up, the output in the economy goes up. You come through the 45-degree line and you find a new aggregate supply function. And suppose you already had a demand function. Suppose you had a demand function. If that happens, clearly the prices will fall and output would increase. So the nominal variables like prices are not independent of real variables. If there is any real change that takes place, either the labor supply function or labor demand function or production function shifts, not the interest rate, not the savings investment line in the labor market, and the aggregate supply function shifts, nominal variable like price will get affected. So the dichotomy is not from the other way around, that real variables do not affect nominal variables. No, real variables do affect nominal variables. Because that's how we have solved the problem. First we solved the labor market real variables, output, then we got the price. So real variables determine the prices, but nominal changes in money supply or anything doesn't affect real variables. So So the classical dichotomy I have written very clearly, real variables are independent of nominal variables. But nominal variables are not independent of real variables. They depend upon them. Recursive model, I told you about recursive model. So this is the understanding you require of the classical model. Slightly complicated, but not much.